Hello, and thank you for listening to this episode of the Night Sky Podcast. My name is Billy Newman.
And I'm Marina Hansen.
And this week we're going to be talking really just about Mars. Right now, it's at its brightest. I think it's for the next 4 days or so. It's going to be at its very brightest that we'll be able to see it. And that's because we're passing a point where Mars has been in opposition. And now it's at its closest point, or I think its brightest point to Earth, its highest magnitude in its series. And so we thought that was a good point to bring up and to talk about and to do kind of an episode that's all about the motion of Mars that people have been seeing and that we've been observing through the night sky over the past month, and then what motion is going to continue for the next month. It's cool how we can kind of forecast it and how it's so, lockstep and the amount of time that it takes to do these certain types of motions and patterns that have been observed for hundreds of years, thousands of years now.
Yeah, it's really interesting how we're able to predict it really to the day. Or mark on your calendar.
Yeah, it's really specific, the timing of these progressions, and they don't seem to be that random. What I understand is if you've been looking up in the night sky, and if you've been listening to us talk on and on about Mars's upcoming retrograde motion in the spring. I think we talked about it even on our first episode. We have made it to that date in the year, and it's pretty exciting. Mars is at its very brightest. It was at its brightest last night, I think at 2 a.m. or something, might be what it says. But effectively what I understood is that really for the whole week-long period surrounding it, it's effectively the same brightness.
That's what I was reading also. For the next week or so, it's supposed to be in about the same position.
Yeah, that's a bit of what I understood also. And it's really exciting. So on June 20th is when Mars passed its point of opposition, which is when it would rise on the horizon line as the sun is setting. Did I say June?
Yeah.
Oh, I'm sorry. I'm thinking in the future already. May 30th. Was the date that Mars was at its brightest. May 20th was the date that Mars was at opposition to us. So it was like a little bit different.
Right.
And I'm not sure quite how that goes. I think just because it's in retrograde right now, that the brightest moment might be different than the point that or the closest that Mars will get to us in its path might be different than the point that it's at opposition.
Right.
I don't totally understand that part of its motion. It's kind of interesting. But it's really exciting though. And we had a great time. For Memorial Day weekend, that's a fortunate thing about this, is see a lot of the times maybe one of these retrograde motions might happen in the winter, when it's not really something that we can observe very well.
Right.
But right now we have the very beginning of summertime, really in the Northwest. At the start of Memorial Day weekend, you can go out and you can look up into Scorpio and technically Libra, when we look up at Mars and see, a really bright object in the sky that really outshines most other things around it. There's Saturn right next to it, which is also quite bright, but Mars is definitely magnitudes more bright or more significant in the sky. And then Jupiter, is a few constellations away, but is still really a strong element in that part of the sky.
It is. It's amazing how bright Mars is.
Isn't it?
It really jumps out.
Yeah.
You notice it.
And it really lights the sky with all three of these planets, these bright planets up in the sky right now. When we were out in Eastern Oregon, we could really see how lit the sky was and how much contrast or silhouetting we could see from the mountains in the distance.
Yeah, it was really interesting.
And if you were to imagine a real dark night, we wouldn't really be able to see that sort of stuff. But what we can see is a contrast just from the light cast in the sky by the stars, which I always think is a really cool part of it.
Yeah, I thought it was really cool too, because we didn't have the moon up for a long time, but it was very bright after sunset, and it had gotten dark.
Yeah, the moon is past its full point. It's going back down to a new moon, I think, in the next few days. And I think it was coming up in Aquarius sometime around 2 or 3 a.m. And so that means that we had really dark skies for the whole first segment of the night. And in that location in Oregon, a dark sky is really great. A dark, clear sky is just a really interesting thing out there, because there's so little light pollution that you can really make out so many more things, or so many more fine details in the constellations that you're not able to see
Yeah.
in the light pollution of city limits as it goes.
It's really very different.
Isn't it
It's
different?
actually hard. It's hard if you're used to looking at constellations from your city. There's a lot less in the sky that you really are able to pick up on. And then I was really noticing it on our camping trip. There are just so many more layers that you can see of the stars, and there's just a lot more in the constellation that than you're really used to looking at, or than I'm really used to looking at.
Yeah.
And you kind of have to re-find yourself.
I think that's really true. And it's interesting how that is. I think as your mind kind of creates the familiarity of the shape or the landmark that you're looking for. And you know, the conversation about light pollution is sort of interesting too, because there are a few factors in it, and a few of them aren't really based on light pollution per se, but really more of atmospheric condition that you're in that keeps you from seeing the bright, crisp part of the stars. You know, I think about people living on the coast a lot, or at low elevations, sea level, let's say. You really get dimmer stars or a dimmer view of things in that area. Which I'm not quite sure of the reason a lot of the time, but it isn't always necessarily due to light pollution. But like what we get out in the mountains when we're really quite far away from a lot of things, then we're able to see just how crisp and bright and dark that night sky can be. But I think out over the ocean, or there's too much water content, and I think you get, I think you get dimmer stars, and especially at lower elevations. That's why I think a lot of the observatories are put up high.
Oh, sure.
On top of mountains, so that they're able to get away from a lot of those atmospheric problems that decrease the visibility of different stars. Light pollution, definitely the number one part of that. But, you know, even in a dark spot here in Eugene, you're not going to be able to see the depth or the number of stars down into the low magnitudes, the really dim stars that are difficult to find, or the dim kind of fine features of constellations. Those are going to be really hard to see unless you're out somewhere that has a big sky country, something that's real dark and flat and pretty dry above you, so that you can get some clear, crisp air to do some observations under. But it was great. Out in Eastern Oregon, it was so fun to get to hang out there and watch the Milky Way rise up over the horizon line, over the mountain in the east of us. That was really cool.
That was really cool.
Watching Vega come up at sunset, or watching it appear, I guess, after twilight kind of took over. It was up in the sky just a little bit. And I think at the time, like, this is a cool part of year because you can see Vega and Arcturus and Spica all at the same time,
right,
which is sort of three of those seasonal stars that we had talked about before that kind of earmark certain seasons coming on. So we see Vega coming up in the eastern sky, kind of curling up out of the northeast for us here, and where that's kind of a marking. It's a star that kind of indicates the oncoming change of the season into summertime. And, you know, it's just, I don't know, it's a small thing, like Arcturus bringing on the springtime, or Capella bringing on fall. You know, as it starts to rise up in the late nights in the beginning of September and October, this seems to be kind of an indicator of, you know, just the changing seasons that are coming through. It's really
cool that there are those little markers that you can look for in the stars that kind of tell you that stuff is changing.
Yeah, I think it's really cool. I like that kind of progression of the year, watching how things like that, you know, move on and change throughout the year. But as we were observing Mars out there, it was really cool. It was up, I mean, really just as right after the sun had gone down, you could really see it and look out. And the interesting thing about observing planets, we might have talked about this, but the interesting thing about observing planets is, so, you know, like we were just talking about with light pollution and atmospheric conditions and how much moisture is in the air, this kind of is an interesting point. So, you know, the twinkling that we see in stars?
Right, yeah.
So you see stars twinkle, but the interesting thing is you don't see planets twinkle. And there's a reason for it, and it's fairly obvious, but the idea is that the starlight is coming from light years and light years away. It's really just a pinpoint of light that's coming through, and it's really uninterrupted for millions of miles, trillions of miles, hundreds of light years. It's able to transit across the universe to the Earth, but as soon as it hits the Earth's atmosphere, then it shakes those photons around. And that's why we're able to see sort of this shift, like when there's ripples on top of water and you're looking at the rocks underneath, how it sort of moves around a little bit on you.
Yeah.
It's that same kind of idea, but just with the oxygen in our atmosphere. And so it moves the starlight around a little bit. And that's why we observe it to twinkle as it kind of comes in and out, or it gains and lessens itself as it goes through what would basically be like a prism of oxygen or water.
That's really
some kind of vapor. So that's why we see stars twinkle. And we see stars twinkle more when, I don't know if it would be the dew point is higher or a humidity level is higher, but essentially when we have more moisture, more water in the atmosphere, if I understand right. And this moisture, I think, is like what is causing the distortion as it moves over. Or hot and cold. Hot and cold can change, just like the convection currents can also make those kind of changes. Like when you see heat waves rising, have you ever seen that?
Yeah,
like the shadows of heat waves rising against a wall or something in the summertime.
Seen it on the heater in the morning.
It's a weird effect. We can see that kind of convection change happening. And that convection change, that movement of the air is enough to sort of move those photons around enough that we see these twinkling. And so if we do see twinkling in stars, where we will not see it is in the planets. So when we look up to Mars in the night sky, or Saturn or Jupiter, like we have up tonight, you won't see those planets twinkle because that is actual reflected light from our sun. So it's a physical surface of light that is receiving light from another source.
Okay.
Does that make sense? So we're actually looking at physical space reflecting light instead of originally emitting the light from a really distant source.
That's really interesting. I think I remember you explaining this to me a little while back. And
right, yeah.
You're right. It makes sense.
Yeah.
But it's not, I hadn't really thought about it.
No, it is interesting. And that's a way that if you're not sure if something is a planet or not, but I guess that's a way that you can tell.
I was going to say, good way to test it.
Yeah. Yeah.
You're not sure if you're looking at Jupiter or just a star.
I think that's one of the simple techniques to try and figure out if you're looking at a planet or not is to see if it's twinkling or not. Like a lot of people confuse, let's say, Sirius, one of the bright stars, for Venus, or for one of the other things, if it's up in the morning or up in the evening, or just if people aren't aware of what Venus might be like, but that star often, for most people observing it, won't twinkle. But if it is twinkling, it is interesting that's something that notes that it's not a planet. It's not reflecting physical light, but it's just a point of light years away from us that's kind of transmitting it to us.
That's a really good star watching tip.
It's an all right one. I think it works pretty well. It's helped me out a few times to figure out what something was, or if that was a planet. Because see, there's been a lot of times where if you don't have the internet as a constant resource for you to check your facts or check your positions on where something is, not that it makes it too easy to do sky watching, but there is a more learned technique of understanding what planet is what after a while of not seeing it. Ways that you can, or I guess characteristics of the planet, like Mars is really red. That might be a good way you can tell that from Venus, which seems to show up really green or yellow green in the sky and stays to a certain area. And so there's these characteristic differences between these planets that we can start to delineate what's a planet, what's not a planet. There's been years ago where Saturn wasn't as bright in its representation in the night sky as it is right now when it's close to opposition, and it was much dimmer in the sky. And you really couldn't identify it separate from the stars around it in a constellation, clearly, right? Like it wasn't obviously like, wow, look at that. That's Saturn.
Yeah.
So I guess at the time, like what we were able to do is sort of look around, and we were able to see just sort of by shape and characteristic of that object in the sky that it wasn't one of the stars that was there, or that it wasn't part of a constellation that I would remember being there. And you can kind of figure out by deduction that it's Saturn, or that it's not, or that it's Mars. Sometimes I've been confused. I'm sure I have.
It's really interesting noticing the little characteristics that you start to pick up on or become familiar with. I've noticed it a lot just this year. I've really noticed the colors of the planets a lot more.
Yeah.
Which I did notice before. I could tell that Mars was red. It was more red than the other ones.
Yeah.
But I I just know it now.
Right.
And it's really interesting how that starts to happen.
There's a level of familiarity that you can get over time. Like Mercury, I think, shows up pretty red in the sky. And at some points in the year, like maybe earlier this year in February, when we had all 5 planets up at the same time.
Oh, yeah.
And Mars right now is very bright. But at that time, like we talked about earlier in the podcast, it was gaining in magnitude every day. It was dropping to like a negative 2.5 magnitude position. Maybe that's close to what it is now. Earlier in the year, it was really much dimmer. So it might be trickier to kind of tell Mercury and Mars apart because they both kind of show up red in the night sky. But there's ways to be able to do, or there's ways to discern like which location or how the planets are aligned. I guess a lot of that goes back to looking at a chart and trying to understand where things are. If you don't keep up with it for a while, you can lose some track of it, but it's something that you can kind of look up and note and figure out what things are in the sky and you know what's going on. But there's some interesting stuff going on with Mars. It's in retrograde right now. Right. I thought that was a big thing that we should talk about, which is pretty cool. It happens every 2 years, if I understand right.
That's what I was reading too. Yeah, we'll see it again in 2018.
Yeah, it's interesting. So do you remember, this was interesting to me. I was thinking back to this. Do you remember back in 2014, 2 years ago in the past from now, right? Do you remember when we were out in the Alvord Desert and we were looking out above Scorpios? It was starting to set in early September in the evening, but we could see Mars and Saturn out there.
I do remember that.
Yeah. And so now we look at their position, which has also come back really quite close to where it was before. Do you remember? Yeah, which is interesting. And really, Saturn has stayed in almost the same spot. Saturn's in prograde right now. Well, in most ways. I think at this moment, it's in retrograde, but it's a small position in retrograde. It'll continue on its path, though, moving back from Virgo into Libra, and then now it's in Scorpio. It'll continue to move in prograde motion back to Sagittarius and then Capricorn and Aquarius. And it'll move through over the next many years, really. I think it's 27 years. That's probably not its same cycle for us, but I think that's its orbital path as it is. But it takes a period of time, a couple years though, for it to kind of move backward in its position in the sky relative to what we see in the night. Back to the same position. So it was in, I think, Libra last time we saw it in 2014. And from that time, it's really only moved back a small amount into Scorpio, where we see it tonight.
Right.
Which is really interesting. And now we see Mars in Scorpio, and we see, the two of them together. We also see Mars in retrograde doing this motion. And what I thought was really interesting is that 2 years ago, and you'll have to follow the dates with me a little bit, but 2 years ago, there's a bit of a cycle that we can kind of see as it unravels. In 2014, the position of opposition for Mars was the date of like April 8th, something like that. So it's 2 years ago and like a month and a half in the past, right?
Yeah.
But now 2 years ago and a month and a half into the future, we're able to see Mars at opposition and in retrograde again, but now in Scorpio. So it's moved from, I guess, what must have been Virgo at the time. Yeah. Perhaps, probably something like Virgo back in April of 2014 when it was up and visible and in retrograde and opposition. Now it's moved over to Scorpio where it's doing that same cycle again.
That is so interesting.
So I'm wondering, maybe it's true, or we could predict that now it's 2016, so 2018 in, what would it be, July?
That's what it says, yeah.
Is it? Yeah?
Yeah.
Something like July? 2018 in July, then we're going to see Mars go through another period of retrograde and opposition, which is really cool. And that'll probably be, cool. I guess, out in past Sagittarius and into Capricorn. So that'll be like a late summer.
Yeah.
Or, yeah, I guess late summer. Yeah. Or like
it goes into August, I think.
Yeah.
I was reading also that it'll be brighter.
Really?
Yeah.
Interesting.
And that's going to be closer.
There's a strange part of this where our orbits in the solar system are not circular.
Yeah.
They're elliptical.
It's really strange. I forgot about that. Kind of, I was trying to figure out how that worked.
Yeah.
But yeah, I guess that's where we'll be on the shape.
Yeah. So there is a significant difference between, the closest part it can be and the cycle where it's, the furthest close pass that we can have. Right. That's why I think, if I remember right, that 2003, 2004 viewing of it, I can't remember. It was a long time ago.
I think it must be 2004 probably.
Yeah, that makes a lot of sense. Sure. Okay. Yeah. That makes sense to me that it would have been that year. I was trying to remember. I was pretty young, but I remember watching it, and I remember them saying that would be the brightest viewing of Mars that we would have for a number of years. And it was pretty cool. It was interesting to, get to see it and look out at the night. But I think that was, the brightest and closest that it was going to be for a really long time is what they had said. I think effectively right now, it's about as bright as it could be. I think they said that the maximum magnitude that we could observe Mars at is a -3 magnitude. I think Venus gets to a -4 magnitude at some times. But, and here's a thing about it, is that Venus will never be at opposition to us. We'll never be able to see Venus rise in the dark sky and then stay up through midnight and 1 a.m. and 2 a.m. through that really dark part of the night and have it rise overhead to a zenith point. Right. We're always going to see Venus really quite low to the horizon, chasing the sun after twilight or in the morning.
Yeah, because it's between us.
Because it's between us, closer to the sun. And so we can see it at a brighter position maybe, but we're also going to see it in the twilight zone of the night sky, that 20 or 30 degrees above the horizon in the west or the western sky, or if it were the morning, 20 or 30 degrees, above the horizon line in the morning, which is pretty cool.
It is cool.
It's interesting how that is, but it's a little different though. So it might look like Jupiter is really brighter, or it might look like Mars is brighter, even though Venus can hit a higher objective magnitude.
Yeah.
It will appear brighter to us because it's going to be such a dark surrounding sky. It's going to be so separate from the sun coming up that we're not going to have any light pollution from the sun, as it were in this case. And we just have really dark skies to get to see it. So it's kind of cool. It's cool getting to see Mars right now. It's really fun watching the retrograde motion.
Yeah, it's been really cool getting to watch it the last couple months.
Yeah, I had some dates about that. So it was like April 22nd this year that it started its retrograde motion. And you and I remember watching it when it was really getting quite close to Saturn there for a while. And so like when we were making those telescope observations of like when we looked at Saturn and the rings at one time. Yeah. And so Mars was really just right over from it for a while. And now that it's in that retrograde motion, it's pushing backward. It's pushing westward in the sky, going back outside of Scorpio and into Libra. And I think now it's technically in the position of Libra. Libra is a weird constellation. Thank goodness we're Scorpios or Scorpiuses. Ugh, what a dumb name. I don't care about the International Astronomical Union stuff about that. I know it is Scorpio, and it's a much better constellation is what I'm getting at than Libra. Libra is like 4 stars that aren't named. There's one of them that's named. I don't remember what it is because it's like it's a second or third magnitude thing. They needed something there to kind of, I don't know, select out what's going on in the sky. But yeah, so Mars is it's past Alniat. I think it's Teshuba. It was really close to Teshuba last week, that one of those front stars in Scorpio. And it's moved past Teshuba and then out into Libra now. It's going to continue doing that motion through the rest of the month, this retrograde motion. It's going to be pushing out further into Libra up until, I guess, you had said, June 30th. Is that right?
Yeah.
Somewhere around June 30th, July 1st. At the end. And that period, that's when Mars ends its retrograde motion and it returns to prograde motion and then starts transiting backward through the constellations in a similar way that the sun does. I think that's what it means, retrograde versus prograde. So how do we say this? So if we're thinking about the constellations and the zodiac signs, let's say we have Virgo in September, we have Libra in October, we have Scorpio in November, and Sagittarius in December right? That's the path that the sun is moving through in the sky. And the sun is moving in prograde motion, let's say. And so this retrograde motion is as the planets are moving along that same path, as Mars moves through Virgo and then into Libra and then into Scorpio, it should move on in prograde motion like the sun into Sagittarius. The term retrograde comes for when it moves in a reverse motion against the path that the sun would take and goes westward across the sky, transits from Scorpio back into Libra like it's doing right now. And then it'll kick back into prograde and continue on out into Sagittarius, I think by end of August, something like that. It's going to be cool to watch.
Yeah.
There's going to be a lot of motion that it does over the next couple months. I think it's going to be, pretty cool to see. I think, what is it, like August? It looks like August 15th or 20th or so. There's going to be a cool alignment between Mars, Saturn, and Antares in Scorpio.
Oh yeah, I think that I had read about that a little bit.
Yeah, it seems like it's going to happen. That's my guess, or it seems like it's about that time, because currently, right now, Saturn is in retrograde, and so it's moving back in its orbit also. But really, its motion is much more subdued. So it's going to stay. Its whole retrograde path is really just a few degrees over the next several months in the constellation of Scorpio. So right now, I think Saturn is a little bit closer toward the tail end of Scorpio. And it's going to move a little closer up to the heart of Scorpio to Antares. And then it'll drop backward and then move into Sagittarius. I don't know, maybe sometime next year or by the end of the year. But we're going to watch Mars, which is in Libra now, drop out of retrograde and then move now back toward Saturn and Antares. And we're going to see that all happen in the next 60 days or so. So it'll be cool to see.
That would be cool to see. I had a question.
Yeah.
So we have the cycle for Mars that's happening every 2 years.
Yeah.
Is it 2 years for Saturn also, or is that on a different
schedule?
Yeah,
that's a good question. So it is different for Saturn. And it's different for Jupiter and Venus and Mercury. And I think it's all based on their orbital path, their motion, or when they come into opposition to us. So how would that be? I think that we're so similar, or we're on that 2-year pattern with Mars. I think because it's just the next planet out from us. It has a similar year for us. Like it's time to rotate or to revolve, to make a revolution around the sun is somewhere around 400 days. Like 405 days, something like that. So it's a small increase percentage wise above what the Earth is. Now for Jupiter, it's like 12 years. For Saturn, it's 29 years, I think. For Venus, it's like 80 days. For Mercury, it's like 75 days. So there's sort of these different pieces that are going to be part of the puzzle. Now, the other part of the puzzle is the position of the Earth in that relationship too. So for retrograde to occur, like what we're seeing with Mars and why that occurs every 2 years for us, is because as we move around the sun, what's happening is like if we were pulling up to Mars at a stoplight. So Mars is out there, and since we're an interior planet from Mars, we're closer. That means that we spin around faster around the sun, and we have a 365-day orbit. It has like a 400-something day orbit. So I guess it's kind of obvious from that. And so what's happening is, as the Earth is behind in the orbit, let's say further back, and Mars is ahead in the circular motion around the sun that we're going to make, the Earth is going to pull right up against Mars, and then it's going to outpace Mars through its path and then move away from it. And so what we're seeing is, as we approach Mars, as we get closer and closer, and then as both bodies are moving through the sky, that's what causes this observed effect of Mars moving in a retrograde motion back westward in the sky against the constellations behind it. I think that's because as time passes through us in the year, and how would I say, like a month ago, Libra would have been in opposition, but now, since it's a month later, Scorpio is going to be in opposition. And so that's why. So as we've moved further over, we're going to be looking back at Mars like if we were looking back at a car that we passed on the road. And that's why it's moving back a little bit. And then it starts to move forward in prograde motion. It's so strange to try and explain. It's really fun though.
Yeah, it's an interesting concept to try to visualize and then explain.
But that cycle happens every 2 years, basically every 2 years and a month and a half or whatever it ends up being. But yeah, there are periods where Mars does not get this bright. It will not be this bright, or it will be more bright in 2.5 years, right?
I think that's what I had read.
Yeah, I think you're right. Now, I've seen in other years where it's really been much dimmer and doing its prograde motion, but it's really been, just a small red dot in the sky.
Sure.
It's really interesting how it is. Or if, in let's say like a year, it gets swung out, to the far side from us, or it's still, it's still in the night sky. It's still on the far side from the sun from us, but it'll really be quite farther away, and it'll look really small and dim. Sometimes Mars is one of the most variable planets, as I consider it. I guess Saturn too, but for as bright as it is right now, it can really be just one of the dimmest little points in the sky. Pretty insignificant and small.
Yeah, this is the brightest I really remember seeing it.
Yeah,
I don't think I remember the 2003, 2004. Yeah. I'm sure that I did see it. I'm sure that I would have observed it, but I don't really remember it that well.
Yeah, I'm not sure.
This is definitely the brightest I recall seeing it in the last few years. I definitely have noticed it being a lot dimmer. So there is a lot of variation in that. That's interesting.
Yeah, there's a lot of variation. And there's another part of it too that I'm not really understanding completely. It seems like, if I remember right, back in like 2003, 2004, that's, or maybe it was 2002. Man, that must have been a long time ago. I was trying to remember the last time that Mars was, well, that's not right either. I was trying to remember the last time that Mars was in Scorpio during its retrograde or during its really bright passing to us. And there seems to be some kind of cycle to that too, which I don't really understand. But if I remember right, that bright passing that happened in 2004 was in those summer constellations. It was in Scorpio or Sagittarius, right in there. Maybe it was in Capricorn by that point, but I remember it being in Scorpio, like for a whole summer, just being really bright and present, just dead center in Scorpio, kind of similar to where it is right now. But that was maybe a decade ago, maybe 12 years ago. It's been in that position since that time, but it's like we're talking about been dimmer, or it's been, just at some other point in its cycle that we're going through. So it's kind of interesting to see these sort of specific things repeat themselves many years apart from each other.
It's really cool. It's strange how it is.
Yeah, it is. Yeah, it is pretty cool. But yeah, we had a great time being out in Heart Mountain in that Antelope Refuge area in Eastern Oregon, kind of near the Nevada border, where there's really nothing out there. That's where you can be 100 miles in every direction from a real town or a real light source that's going to be, any issue for you. But it was really cool, looking out and just seeing like one light or two lights. I think it was like 80 or 90 miles away in French Glen. That's everything you could see out there. So it's pretty fun. It was cool being out and cool getting to do some observations of Mars while it was at its brightest point in retrograde. That was pretty cool.
Yeah, it was really cool. I'm so happy that we got to be out somewhere with a really good sky to observe it while it's at its brightest. Yeah. You could see it in town, but it's different when you get to see.
It is different. Yeah. It's really quite a show, like out in the dark.
Yeah, it's great. Yeah. I'm really enjoying doing that.
Yeah. It was really fun. Doing the observation side of it is definitely the best part of it. It was cool pulling out the telescope for a while.
Yeah, I'm glad we brought it with us.
Looking at Mars through a telescope. It's not that rewarding though. I think we need a much bigger telescope.
Yeah, I think when we were looking through it, I was thinking it seemed about as bright when I was just looking at it with my eyes.
That's really true. That's what happens when you look at stars too. Unless it's like a feature or like a cluster or something.
Yeah, that's what I noticed. I think like Saturn was really cool to look at with a telescope because you can see its rings.
Yeah.
And Jupiter.
Yeah, there's something really observable about it.
Yeah, you can see the moon.
Yeah, the moons are great to see. That's really fun.
Banding.
Yeah. Yeah, you can make out more moons on Saturn too if you have a better telescope than what we're looking at. Cool. Yeah, you can see Titan and you can see a few others. I think you can see like I think you can see 5 moons around Saturn.
Wow, that would be so cool. I want to upgrade our telescopes.
We got to do it. Yeah, we got to get like a 6-inch refractor, something like that. I think that's when you can start making out better things on Mars too, like the ice caps. You're supposed to be able to see that. Yeah, if you look at, you're supposed to be able to make out sort of the white top of the planet, which we're really not quite able to do. We're not able to make clear details out through what we're looking at.
Yeah, not
quite. Hey, look, it's red.
It's a little toy telescope.
Yeah, practically. A little toy. But it's been pretty cool to use or to
it's really
make
fun.
Some observations with. It's been fun. It's a good camping telescope.
It's a great.
I'll throw it in the back of the truck.
Telescope. Yeah, I want something that I can do that with.
Yeah, but it was cool. We got to see a lot of stuff out there this weekend. Watch the International Space Station go by. That was fun to see.
That's right.
Have you seen that many times
really
before?
Great. I think only a couple of other times, really.
Yeah. Yeah, it's cool.
That's the brightest I've seen it and the longest I've seen it, I think.
Yeah, it was cool catching. I think even that second night we caught a view of the International Space Station going over in almost the same path.
Yeah.
Yeah, and it's kind of cool. It's interesting how it goes. I'm not really sure that the pathway or the timing of it, in its orbit, or like when it's supposed to pass by every night, or what location. But really, that's what you can tell. You can tell the difference between the International Space Station and other satellites just because of its motion and its pattern, where it's coming from. Most satellites, almost every communication satellite that we're going to see in the Northwest here or over North America, is going to be a north to south based satellite or a south to north based satellite. It's going to be happening, I don't know, just kind of a little bit east of the zenith point in the sky. That's where you're going to see most things, but you really won't see that many objects do a strange transit, like something from the southwest to the northeast, or sometimes you'll see it from the northwest to the northeast. You'll see it kind of move in all sorts of different directions, and that's kind of an interesting thing about it. But that's kind of the key feature, that, and that it's significantly brighter and more sustained than other satellite objects that we're going to observe. The other satellites, like we might see, I think we also saw flare as they pass that bright spot in the sun. So they get really bright. They get as bright as the International Space Station, but then they die off, or they get a lot dimmer. And that's as they fall out of the sunlight, out of the twilight point there, and then back into the night where there's no reflection to kick off of the solar panels that it has to make a real bright mirrored look in the sky. It's kind of cool, though. It's interesting to see and to sort of figure out, like, oh, that weird anomaly that we see is for this reason. It's kind of cool.
It is cool.
Yeah.
Yeah, it was fun observing that, too.
Yeah, yeah. But I guess we'll be back sometime this next week with a bunch of news about Saturn and its opposition that's coming up, and the observations that we can make of the rings. We should talk about that tilt pattern too.
Oh, yeah.
The times, through the decade that we're more able to see the rings versus times when we're more on a flat plane with the rings and we're not able to see them. An interesting effect, but we should talk about that coming up on the next episode of the Night Sky Podcast. But hopefully you guys are enjoying a few of the things that we've been talking about on the Night Sky Podcast. If you have any suggestions for us, please shoot us a comment. The website's nightsky.io. If you want to subscribe, please go ahead and do that. Leave us a review if you'd like to. I think that's just about everything, right? You can follow me on Twitter at Billy Newman. Marina, what's your Twitter handle? Or Instagram or whatever?
Marina Rose Alice, I think.
That'd be cool. Yeah, we should put that sort of stuff in the podcast that we do too. But on behalf of Marina Hanson, my name is Billy Newman, and thank you very much for listening to this episode of the Night Sky Podcast.